Right. Could you see this monitor? Really? So the Vim part of it, you don't have to use command line. So I added to the environmental variable because I want to directly start the gvim using the command line. If you're using a Mac, I think you can directly start from the terminal, right? From the terminal. Or Linux, you can start from the terminal. So, or you can double click it to start it. It's just starting the editor. Okay, pretty simple. So the main goal is to practice all these VI commands. It's because in the future, when you are working with other digital engineer design or engineers in the company, most likely you have to log into the server and using the VI editor for it. So for the VISI class, I think starting from lab 9, we just have to log into the Cadence server and go through all these VI commands to edit the scripts in Cadence. So it's something you guys have to learn how to do it. Critical, okay? So today's lab is mainly for set up the environment. It could be Vivado and Vim on our laptop, or find out the desktop you want to use or comfortable with. And in the future, you come to the lab, we'll directly use that equipment for the lab in the future. Okay, identify a equipment for you for the semester. Okay, and practice all the Vim commands. Prepare for a quiz for next week on Tuesday in the lab. And start Vivado. It's a closer look onto the chip's version. It's RTX 7, it's the name of the chip. And I think you need to know this serial number as well when you are selecting the correct device in the Vivado setup. So when you are starting a new project, you need to define that package in order to pick up the correct one, which is this guy. I think it is specifically it is 7A35 TCPG 236-1. Okay, I had a students picked up the wrong one, eventually cannot synthesize or compile the code. Very critical, right? So when you have this Vivado window opened, you could either right click, you can see the design sources. This little window, and you can right click and add sources. So the sources are basically just the Verilog files. The Verilog design files, something.v files. You can right click and add multiple Verilog files into Vivado and run the simulation. So for this lab, it's really simple. I believe it's just a andGate simulation. So I name it as andGate. So it's getting loaded into it. So time scale, it's 1 nanoseconds per division and 1 picoseconds for the precision for the simulation. So 1 nanoseconds means it's a time unit. If you directly throw a number into Verilog, for example 10, okay? Because you are not having any time units in your Verilog code, it's not compatible with the syntax. So if you directly put a 10 in there, if you define that as 1 nanoseconds over here as a time unit, then that means 10 nanoseconds. You'll see this a lot in the simulation files. So 10 means 10 nanoseconds because you define it as 1 nanoseconds for the time unit. So 1 picoseconds is the precision of the simulation. It means it cannot go lower than 1 picoseconds for the resolution. Right. You can take a look at this one. It's a very simple andGate. I think we cover about the syntax of Verilog in the lecture today really quick. So take a look at it if this is familiar to you. What's the difference? Let's try to answer this question first. What kind of modeling method is this guy's using? Data flow method, because it's assign, right? It's assigning something to something. So data flow modeling. You can see the module, N module is andGate is the name of the module, and you have the ports. So you could either define the type of the ports inside the parentheses, But I think for the examples in the lecture, we specify the type of the ports behind or under this first line, right? So you can either just throw the ports name in it, or you can specify the type of the ports in the parentheses as well. Either way, doesn't matter, right? Yeah?
So it doesn't matter if the input and output, which one is at the beginning?
Usually we do input first. I don't think that matters, but yeah, better practice, right? Just use the input first and then output. Yeah, it shouldn't matter because, for example, if you don't define it this way, if you use the same way that as what we define in the lecture, so we don't even have input and output in there, right? So we just have A, B, Y in there, and then we define the type of the ports just right below this first line. So it's going to be like input AB, output Y, which also works. Okay, let's talk about test bench. So the way that this works is, if you grab a little chip from the drawer in the lab, for example, we have a lot of, you can see, look at the drawers. There are just so many different components in the lab. It could be andGate, inverters, or gates. Doesn't matter what that chip is. Right, so if you have a component, it's very similar to a little chip you grabbed from the drawer in the lab, like an andGate. Okay? So this block doesn't have any connections to anything. If it's just a chip, it has ports and it's logic, whatever logic inside, right? So the thing is, if you want to run the simulation, you have to connect the pins, inputs and outputs to signals or to probes. You want to connect signals as an input, or you want to probe the output to see what's going on inside the block, right? So for Verilog simulation, we use another module. It's also a Verilog module, but it's called testbench. The testbench, you can put signals into the testbench. It's just another layer of design. So this is the module, right? It has 3 ports. So for testbench, it's another Verilog file, no difference. It's just another Verilog file. So you're drawing a box, all right? So another module, .v file. And you're assigning signals into the ports, and then you probe from here. So the testbench is very similar to the breadboard. So you plug in your chip into the breadboard, and then you make the connections to the benchtop equipment, like the signal generators or the oscilloscopes, things like that. So let's take a look at the code of this testbench. Okay. It shows the module, unmodule, and then you have all these Verilog code in the middle. Wire, just a wire. Just a wire. You can continuously assigning signals to it. It's not being clocked, not being controlled. Just a wire. And A and B, you need a register type because you are assigning values to it, so it's able to store these values in your initial begin and end statement. So you're able to store, it is able to store values for a certain period of time, like 10 nanoseconds. Remember what I told you? If you throw a number in Verilog, and you define it as 1 nanosecond as a time unit, so 10 means 10 nanoseconds. Okay, so 10 means 10 nanoseconds. It doesn't have ports because it's giving signal into itself. It doesn't need to accept anything from outside. Okay, so you can see that. But later on, when we are dealing with FPGAs, we do need a testbench with ports in it, because eventually the testbench is another digital module which has to be connected to the switches or LEDs of the FPGA board. So these are ports that I have to use to connect to the physical signals on the board. What does this mean? This is a major part of the testbench, this one. So if you pay attention to this name, It has to be the same name as the module you created over here. It could be confusing. Pay attention to this, okay? So this module is called andGate, capitalized, okay, andGate. So when you are trying to instantiate it, you just have to write the same name as this module, andGate, and it's case sensitive, right? So andGate, and you rename it within your test bench. You can name it as DOT is the device under test, or could be anything else. Doesn't matter. Okay, DOTT doesn't matter. Doesn't matter at all. You just rename it. You instantiate it and you rename it, and eventually place all the ports over here to make the connections to the andGates, andGates ports. That's another interesting thing. Probably we can cover that on Thursday. It could be confusing. You can see this guy has andGate has A, right, B, and Y. And for your test bench, let me just make it smaller so it's easier to look at both. So this module, this sub-module has A, B, and Y as ports. Agree with that, right? Apparently, that is true. If you look at the test bench, we need to give different names, even though I use the same name, but it really doesn't matter. I named the same as whatever I named, you know, for all these ports for the andGate. But however, you can name it as, for example, AA. It doesn't matter. AA, BB, YY for the test bench. Okay, so which means for these names, I can name them as AA, BB, YY. It doesn't matter. It's the test bench's signal lines. It's not any ports for the sub module. All right, but the thing is, what they are here inside the parentheses. What are these signals? If you use the same names, it's confusing, right? Are they the signal lines from the sub module, or are they the signals from the signal lines of the test bench? Yeah, it's the signal lines from the test bench, but usually I don't do it this way because it's confusing, right? It's confusing people. So the standard way to do that is, let me start a GVim. I'll just type it in the text editor. Open the text editor. Let me show it to you. So just for this line, all right, just for this line, it's case sensitive. Keep in mind, DOT or DOT, it doesn't matter. It's just a name. Okay. Usually, what I do is dot A. So the port name right after that dot. Hopefully, you can see it. So the port name right after the dot is a port in the sub module. Is the port of the andGate. Keep in mind. So the port right after the dot is a port within that sub module, not the signal line of the test bench. And you want to make a connection to the signal line of the test bench, comma, and dot B, B. Okay, comma, dot Y, and Y. Parentheses and semicolon. All right, that's how I'll do it. You'll see a couple of other examples in the tutorial or in the lab. So now I understand what's going on. So the signal line right after the dot will be the signal line with the port of the sub module, not the test bench. Keep in mind. Okay, just remember this. So I assign a 0 to A and B individually, and immediately I delay it for 10 nanoseconds. Okay, so what's really happening is, so for A and B, I give A, B zeros, and that's just the one dot. Keep that in mind. There's an example in the homework assignment in the tutorial of lecture 1, the basics. So we're going to work on that this week. Keep that in mind. You give a 0 to that signal line. It's just one moment. It's just one dot. It's just one dot. You give a 0, boom, just one dot as a 0 voltage. It's ground line. Okay, and then you extend it for 10 nanoseconds. So it's going to be a 0 volts for 10 nanoseconds. So extend it by 10 nanoseconds. You got a dot and then 10 nanoseconds. Right, and then A is not changing because after 10 nanoseconds, B becomes 1. Keep in mind, it's just one dot. Right after this guy, it's just one dot. Then 10 nanoseconds. I mean, it's time, right? Time is for everyone on this planet. You cannot hold A there in that second, right? So yeah, it's gonna work. It's gonna work same for the for A. It's not changing. And after 10 nanoseconds, you got 2 more dots. Okay, so A, you got a dot for A, which is 1. Yeah, you can draw this line. B will be a dot at 0, drop to 0. Okay, right after this, it's going to be just 2 dots. One more time. Then extend it by 10 nanoseconds. And 1 more dot for B, so you change it to 1. And extend it by 10 nanoseconds, so this is not changing. All right, let's look at this logic. What are they? 0, 0, 0, 1, 1, 0, and 1, 1. So it's going through all the possibilities of combinations of these 2 input binary number, so you can verify the logic of the output. So you want to give all these combinations of the possible combinations of 2 inputs. So you can take a look at the simulated output, and so you can verify if this is an andGate. So for simulation, after you created this test bench, it's going to directly detect this andGate as a name from the name and put it under this test bench menu, so you can see these are associated with each other. So however, if you, for example, if I change the name here to something else, like lowercase andGate, it won't be able to detect this module anymore. So you won't have this kind of hierarchy in your Vivado interface. So the andGate module will be somewhere else. It will be probably under another design source. Okay. Another really quick question. So I kept the name of the file and the name of the module the same. Okay. Do we really need the same names for these two names? The file name and the module name, do they have to be the same? So the question is the test bench detecting the module's name or the file name? The file name has a something.v. Detect the module name, yes. So you can name the file something else. It doesn't matter. So eventually it's able to detect the module's name. And do you have to keep the test bench and the module in different files? They can be in the same file. You can have one super long Verilog file has all different modules, but you just have to have the module start with module and end with end module, like this. So it's going to be identified as one module, and you can have like as many as you want, 100 modules in one file, doesn't matter. And whenever you put into the simulator or whatever the digital design tools, it is able to pick up that top module, which is the test bench. Keep in mind it's top, so always being called top. The reason for that is in the future when you have multiple designs in that system, okay, like a box, there might be multiple modules like this. Okay, so you can instantiate all these modules in your top design. So these are just the individual modules, right? Your module and module, these kind of things, and all the logic inside. So you can instantiate the 5 different modules. For example, I have andGate DOT like this, and I can do OR gate What about the name? It has to be a different name, I believe. Assuming that they have the same port names, which doesn't really matter. For the sub module, however, for here it has to be different module. That could happen, right? Doesn't matter. It'll be just something like this. And or, right? So they are using the same input. Okay? But two different outputs. Alright, so for example, we have another OR gate as a module, and I want to include it in my test bench or the top module. So I have the OR gates or the inputs being connected to the test benches signal lines A and B is the same port name because they are shorted to each other. This is A. This is B. So it must be a different name here. Yes, it must be different because they are outputs, right? Yeah, you can keep adding different modules and instantiate different modules in the same top module or test bench. Okay. Let's see. All right, this is the final simulation results. So I think Vivado has a limit on simulation time. I forgot, it's 200 nanoseconds or something. But eventually, we only have 4 combinations, so it's definitely sufficient for us. If you look at the tasks, have the Vim and Vivado set up, right? Practice with the Vim commands and prepare for the quiz next week. Right? That's everything about the lab for this week. After, if you can get everything done quickly, you can go back to the tutorial and start working on the simulations required by the tutorial, which is over here, right? This one, and I believe should be able to do which. Yeah, that is the first one. You'll be ready. You should be ready to do the first one. So the problem is sections 2.1, 2.2, and 2.3. Okay, so for the lab reports, it's going to be you can directly use any other editors, but most of the people will use Microsoft Word, which is okay. So you make snapshots of the critical steps and results, or code, whatever. So make snapshots and copy and paste into Word and convert it to a single PDF file and submit it to Canvas. Okay. Any questions by far? So all the rest of the tutorials will be covered on Thursday, and we will have a quiz 2 on structural, behavioral, and data flow modeling methods, but closed book, closed notes. So today in the lab is a good time to practice all these modeling methods. So start typing using Verilog and be familiar with it. And also for the quiz in the morning, please submit it to me, the paper copy. Probably, let's say, I'll give you 10 more minutes. Okay?